Hello again. Uh, Welcome back. Today I want to do some pulse width modulation controlling some LEDs. At first I thought that would be completely trivial and too easy to do even a video on. I did it before on the standard library, the IDF framework, in a few videos back. However, I now wanted to do it in a no standard, in a bare metal setup with um, Embassy. So I thought it was really easy, and I was kind of wrong. I think it was a lot more complicated than I expected. So I think it makes sense, and it's easy, and it's nice to have something that gives the controller some good way of outputting data somehow, aside from just logging to the logging stream, which is a bit lame. So today I want to do some PWM. So pulse width modulation. It's basically what we use for now for LEDs is just basically switching it on and off really quickly, so you can individually dim and brighten different color LEDs, so you can kind of pick the color. But it's not like that the voltage actually changes, it just switches on and off quickly. You can also use it for servos. Servos are also used, controlled by a pulse at a way lower frequency. I think servos are typically like 50 Hertz. LEDs tend to be higher, but above what the human eye can see, I don't really think it matters. There will not be an awful lot to see during the programming, only at the end, so I'm gonna switch off the desk cam. So yeah, let's get started. So let's do the template. Let's call it ESP32 LED. We're sticking with the C3. There's a S3 one coming up as well. I bought one, it's nice. Advanced, yes. Alloc, yes. No dev containers, no vocree, no CI. Logging, please. Wi-Fi, let's do it. We won't be doing Wi-Fi in this one, but you never know. Let's go with this. Just get reconnected. Flash it just to see if all the compilation works out. And here we have a brand new project with the main, with familiar setup, and doing a loop in the end. All right, so so to get started, a good place to start looking is in the hardware abstraction layer crate, so the HAL. In this case, we are looking for the LED-C subcomponent module. So that's right here, and that's a peripheral that can change those frequencies. So you can configure that. And there is an example here. Low speed, I mean they call low speed, but it's 24 kilohertz, so that's more than enough for what we want to do. And if we look at that, we see we instantiate one based on the LED-C peripheral. We create a timer. We need a timer as well. There are a few, I think 4 maybe on the C3, but you can use the timer for many different controllers. You configure it to a frequency basically, and then you need a channel which you associate with a pin. This is a pin. And then finally you configure it to use the timer, and then a duty cycle. Duty cycle is, as far as I can tell, always a percentage between 0 and 100, which is kind of odd to me, but there you go. So this channel object is a thing you can set the duty on. You have a set duty, and that will basically set the brightness of the LED that's configured to that pin. So the compilation has succeeded. It's just printing loop every other second or something like that. So that works. Let's get back to our code. So here, let's have a look. Let's take this example. Again, I'm saying it pretty much every time. I don't really like the copy-paste example programming style, but that's how this scene seems to work. So let's roll with it. Let's go through figuring out what all the missing imports are. I think this is just clocks. And just doing some imports. So it sets the global slow clock. I really not sure, but it seems to influence the timer. I guess it's this timer. That's always a bit tricky because a lot of things have the same name. Let's see, channel, I suppose. Yes. And this is then a pin. We need to get, import this one. So this is not using the right import, I suppose. Let's see. Let's start with making getting a pin. So for that, we pretty much always make a I/O object. It's all over the place. So let's let I/O equals I/O. What was it? New. And then system peripherals. No peripherals. GPIO. And peripherals I/O. I don't know what it really is, but that gives access to the pins. Okay, so we will need 3 pins to configure the color, and for my developer board it's pin 3, 4 and 5. Pin 3 is red, 4 is green, 5 is blue. So yeah, we need those 3 pins to do anything. So let's start with the red pin. Let red pin equals IO dot pins dot GPIO3, and we add that to this one. So that seems to work. We configure that, and somehow how IO no. Let's see. This is the one. Let's see. That's weird. Oh, I guess the example is out of date somehow, which is a little bit odd. I hadn't noticed. So let me have a check. Pin config. And that's push pull on open drain. I have the feeling it's not right. let's have a look at the channel object itself. Okay, so what do we need to add here? We have a timer, a duty percentage, and a pin config. Timer, duty percentage, pin config. Okay, now the timer is there, duty percentage and pin config. That's then push pull, I think, what we saw. What's wrong here? The percentage is U8, that should be alright. This must be something really dumb. Ah, of course, yeah. It needs to have the pin config. Okay. Let's remove this. Import it. Okay, so this would mean that if we run all that, let's do a little bit more. It should run the pin at medium brightness. Alright, let's see if it does anything. So it should be the central LED, which is kind of there in the middle, should be red. Indeed it is. And if we go to 100, then it will maybe it's hard to see the difference in brightness. Let's try anyway. So then it should be brighter, right? And then we can, while this is going on, we can add some more pins. So we have the timer, but we can reuse the timer. We can use it for all the pins, but we need to make 3 channels for each color, right? And we need to have 3 pins. So now, yeah, I don't know if it shows on camera, but now it's definitely brighter than it was before. Okay, that's nice. Let's continue. So we have the red pin, green pin, and the blue pin. Green pin, blue pin. That's pin 5. No, pin 5. This is pin 4. So let's create several channels for that. So you can see that it gets pretty messy pretty quickly. Like it's not. It's a lot of code, and actually it is kind of tricky to isolate it, but I'll get to that. Why is it complaining? Well, let's continue with this first. Maybe clean itself up. kind of wondering why this one needs type annotations while the other one didn't. There's probably some copy paste error. Yeah, it is. So not the prettiest code in any case. So now we have 3 channels, and if we let's put the first 2 on 100 and the last one 0, so then it should be yellow. And while this bakes, we can continue. So this is not something you want to have in your main function, right? You basically want to create a thing, and then a thing, and then you have a thing, and you can say set color or something like that, and then you give it some look, it's yellowish. Yeah, it's yellow. But you want to have something you can give some coordinate, and then that's what the LED does, right? So and not having all this stuff in here. So let's try to clean it up a little bit. All right, back. Yeah, so we need to move this code into something that's a bit more manageable. So let's first start by creating a module, led.rs, something like that. We need to include that here. Mod led, and let's create a struct there. And let's call it something like LED component. So what do we put in here? I think the best thing to put in here are the channels themselves, because we could also put the pins in here and keep the channels internal, but that gets a little bit tricky with ownership. Ownership is always a little bit tricky in Rust, especially given in the embedded space there is a lot of ownership that is not really a thing. Like if you create a component to take ownership of those pins, most of the stuff that you make will gonna live forever anyway. So it is a little bit tricky. But if we're getting into something like Embassy, then you do need to make some guarantees. You need to, for example, make sure that everything you're using has a static borrow lifetime, so that it's there forever, and that's a little bit of an extra burden. So let's put the channels in. So a channel is a low speed with a GPIO pin. So red is a channel. Let's see which one, and that needs to have some a lifetime, low speed, and GPIO pin. So that means that this thing needs a lifetime. Call it B low speed, and let's start with GPIO 3. And that's output and push pull. That's a lot of generics, right? So red, green, and blue. So that would be pin 4 and pin 5. Let's see if we can construct it. Component. Okay. Channel 0. Is that correct? Not quite. I didn't configure them to use output. Yeah. But yeah, it doesn't seem to matter somehow into output, I think. Push-pull output. Yeah. All of those. Weird that it didn't catch that, but it probably is some reason for that. And it says it's private. Okay, yeah, that makes sense. So we make them public. Or we can create a constructor. It's kind of prettier, but anyway. So green, channel 1, blue, channel 2. All right. So that works. Let's make it a little bit prettier and create a constructor. So we need to make an implementation block with the lifetime, and we make a function, a public function, new, that takes all this give it the name red channel. We create red, green, and blue, and it returns a self, and then we do a let component with the short form. So red, green, blue. Don't need to add the names if they're the same. Yeah, I think that's okay. And if we refactor to that, we can just do new zero. A little bit prettier, and then we can say add another function, pub function, set color, red U8, green U8, and blue U8, and of course self. mutable self, and then we say self dot red that's around here. Somehow there's something wrong here. I have no idea why it seems to really weird. It didn't autocomplete that, and I don't know why. Anyway, so I'm gonna set the duty to the value for red, and also for green and blue, of course. Green, green, green. What happened? Oh, blue. Got this one wrong. Alright, so let's see if we can get this to work. So in that loop we have our component, right? We make it mutable, and we say component set color. Let's start with, I'm not sure it's going to 100 or 99. It worked at 100 at least. So we take some colors. Let's be patriotic and make it red, white and blue. And then delay between. Right? I'll do next one. Let's see what that does. I had the camera there all the time. I hope it wasn't obscuring too much. Forgot to switch it off. But I think most of the code is higher than that. Red, white, blue. Red, white, blue. So that's actually not that bad. But there are some things I think we should still improve. Let me switch to the camera now. Let's see. So one thing that's not so nice is that the pin numbers are now hard-coded in this component, right? Because we end up, yeah, if you use the exact board, it's fine, but if you need a different one, you don't really want to get into the code. So let's create some generics to do that. So the way that works in Rust is by using generics. So we say red, so that's not a value, it's a type. It's an output pin. Green, it's an output pin. And blue, it's an output pin. And then instead of this, the GPIO output push pull, you're gonna say an output pin. So red. And green, then we need to add those generic as well. Blue here, and also in the definition. So these exact same. So you end up copying those generics all over the place. And again, then we're gonna replace those here with red. Green and blue. There we go. That worked. And this one seems to just have worked, right? Even though red is now no longer a concrete type, but it's a generic. Okay, let's see what this does. And this also works. So that was not too bad. Let's make sure it's not. It seems to compile just fine. So that's pretty nice, right? So then at least we're not really dependent anymore on the exact pin. Let's move this to use embassy. That's always a bit of a. It's not a struggle, but it's a bit of some work. Yeah, I'll do that next time. I think this one has gone long enough. It's nearly 20 some minutes. So I'll do that next time. But I hope this helps you. If you want to get into the embassy part, the whole ownership thing gets a little hairier. But yeah, if you have ideas or tips, let me know. I'm now in the process of working with S3 with a display, which is pretty nice. So that's up next. Using MQTT is up next. And some general interaction with peripherals. I think I2C maybe. But we'll see. So please leave a like and let me know what I can do for you. If there are tips or something, let me know in the comments. Alright, see you next time.